EV or PHEV, plug-in hybrid electrical vehicle, in existence. But going back to the direct drive, we have the electrical motor, we have the combustion engine, the electric motor sitting on the crank, and then we have what we call the hydracoup, or the hydraulic coupling. This is before we get to the final drive unit and those electrical motors. So with no gearbox and no neutral, how can you run the engine while standing still? Well, we say we have a hydraulic coupling that we can open up and close pretty much, but it also has a torque converter effect into it. And in many ways, what we see in front of us, which is the hydraulic coupling we've designed for the car here in-house at Koenigsegg, is a traditional lock-up torque converter taken to the extreme. Normally you would find a lock-up converter in an automatic transmission car. The converter itself without the lock-up function was invented, I don't know, 100 years ago or something like that. And it manages to convert more torque when you're driving slowly through a hydraulic turbine-like process. And I think why this isn't being used by other hybrid cars, we know no other using it for a hybrid drive, is because it's kind of not it's old school and unobvious in a high-tech environment. But it does some really cool things that makes the direct drive work really well. We could use more of a traditional clutch and still make it work, but we wouldn't be able to accelerate as fast in combination with having that kind of top speed we have without it. So I will open this up and look a little bit inside for you guys. We also talked to torque converter manufacturers to see if they could help us do something like this. But it was really difficult to explain our needs and for them to get the head around what we were doing, or even have an interest in doing something in low volume. So that meant we had to develop it ourselves and get basically experts on hydraulic turbine technology, which a torque converter is. The difference between a normal torque converter and this one is that it's much lighter compared to its size, as it's all machined aluminium in every aspect. The other aspect is that normal torque converters the engine and the torque converter takes off and the car takes off in first gear. So it has a certain resistance compared to the power because the car is in first gear. Our car, or the Regera, is in the equivalent of 7th gear, as you can, with no gears, drive 250 miles per hour without shifting. Basically, we are in the 7th gear of the Agera. That's our final drive ratio. So it has a much tougher job than any torque converter before it, because we're putting 1200 combustion engine horsepower and 160 kilowatt or 200 horsepower of electrical motor that sits on the crank. The other electrical motor sits behind this unit, so it's unaffected by it. And you're in 7th gear and you're standing still. So we had to come up with completely new blade designs to convert more efficiently on a higher level of conversion than before. This is the stator unit that also kind of acts like an oil gear inside the torque converter, and this had to be designed very carefully, again, to have as low stall point of the torque converter as possible. And as you can see, it's all beautifully machined aluminium, and compared to its size, we have more surface area for torque conversion and more fins and much lesser weight. On top of the torque conversion function, where basically you put in 1 RPM, let's say you put in 2000 RPM, but only 1000 comes out with more than double the torque, you can say. That's what the torque converter does at low RPM. But then you lose some efficiency when you torque convert. You get more torque, but you lose efficiency and you create heat. So you don't want to do that too often, but momentarily it's absolutely fine to get the car rushing away or something like that. But if we're not pushing full, there is no reason to use the torque converter. Then we will take off more on the rear electrical motors to have less energy losses. And then we feed in this hydraulic coupling, which is more like a traditional hydraulic clutch, where you have these brake bands. So you don't actually have to use the torque converter, but for maximum acceleration, it doubles the torque. at low RPM means it's more acceptable to be in such a high gear. So this is really a key component to make the direct drive work really well. And to put it into perspective what it can do, if we turn off all the electrical motors and just take off on the combustion engine, then we can go 0 to 60 miles per hour in about 4 seconds in 7th gear with the help of this thing. If we turn off the combustion engine and just run on the rear electrical motors on the rear axle, we can again go 0 to 60 in about 4 seconds, because we have almost 500 horsepower only on the rear axle, but again with very high gear ratio as they're direct driving on the wheels. Otherwise it would be shorter than 4 seconds. But then combining the two and then feeding in